look at some examples. I'll start by a simple one. It's, example 1. Find Fourier coefficients of a signal xt given as cosine 10 pi t plus cosine 20 pi t. Can you tell what are the Fourier series coefficients for this signal, for this simple signal? No. I'll solve this question in 2 different methods. One of them is easy. The other one is also easy but long. I'll start by the easy one. The first thing to do always is to find the period of the signal, because so far we're dealing with Fourier series, and Fourier series coefficients can be found only for periodic signals, and also only for finite for signals with finite energy, so over one period. So first we need to find the period of this signal. What's the period of this signal? Okay, I'll find it here, but you should be able to do it because you have taken this from a long time and you will be using this a lot for Fourier series. First, for this part, let's call it T1, 2 pi divided by omega naught. Omega naught is 10 pi. So this would be 2 pi divided by 10 pi will be 1 divided by 5. And the period, the fundamental period for this signal, let's call it T2. Again, 2 pi divided by omega naught. Omega naught is 20 pi in this case, so 2 pi divided by 20 pi will be 1 divided by 10. Next, we need to find the fundamental period of this of the whole signal, and this is given by T naught is the least common multiplier between T1 and T2, which is least common multiplier between 1 divided by 5 and 1 divided by 10. And the least common multiple between those two numbers is 1 divided by 5. So the period of this signal is 1 divided by 5, and the fundamental frequency of this signal in radians per second is, as we have seen here, it's 2 pi f naught, and f naught is 1 divided by t naught. So omega naught is 2 pi divided by t naught. 2 pi divided by t naught. which is 2 pi divided by 1/5, which is 10 pi. Okay. The next step is generally you should start from here, from this equation so far, but later on in the course you will learn some other tricks to simplify the calculations. But for this example, for this method 1, let's call it method 1. I'll start by writing those cosines using the Euler's formula. So from cosine theta is exponential j theta plus exponential minus j theta divided by 2. So I write now this xt, those cosine, two cosines using this formula. So xt will become, we have the first term, let me rewrite it here, cosine 10 pi t plus cosine 20 pi t. And this will be, if we use this Euler's formula, we get 1/2 exponential j 10 pi t plus exponential minus j 10 pi t plus 1/2 exponential j 20 pi t plus exponential minus j 20 pi t. And if we use omega naught is 10 pi. Omega naught is 10 pi. If we use it here also, 1/2 exponential j omega naught t plus exponential minus j omega naught t plus 1/2 exponential. Here we have 20 pi. Omega naught is 10 pi, so it will be j 2 omega naught t plus exponential minus j 2 omega naught t. Let's rearrange the terms. I write them this way and you will see why. 1/2 exponential minus j omega naught t plus 1/2 exponential j omega naught t plus 1/2, excuse me. I start by the term with -2, so 1/2 exponential minus j 2 omega naught t plus 1/2 exponential, then this term minus j omega naught t plus 1/2 exponential j omega naught t plus 1/2 exponential j 2 omega naught t. And this can be written as a summation one half exponential minus j k omega naught t, but k is only k is from -2 to +2, and k is not 0, right? Because we have 2 omega naught minus 2 omega naught minus 1 omega naught 1 omega naught and 2 omega naught. So it's from -2 to +2 except the 0. And this is always constant for all of these terms, which is 1/2. So we have found the coefficients for the Fourier series, which is 1/2. Let me write it piecewise. So it's 1/2 when k is in ±2, ±1, and 0 otherwise. Those are the Fourier series coefficients. We have only 4 terms, ±2, ±1, and then 0 otherwise. So the Fourier series coefficients for this signal for xt equals cosine 10 pi t plus cosine 20 pi t is purely real number. There's no imaginary. So the phase of this is 0. It's pure real. We can plot it this way in terms of k omega naught. And as we have shown, omega naught is 10 pi, right? Omega naught is 10 pi. So if we plot this AK will be 1/2 at k equals minus plus 1. So k equals minus plus 1. So k equals 1, and then so this will be minus plus 10 pi. Minus plus 10 pi, and we have half here. And also minus plus 20 pi. This is when k equals 1. And this when k equals minus 1. And then we'll have also 1/2 when k equals 2, which corresponds to 20 pi, and also minus 20 pi. And the signal is purely real, so the phase of AK is 0 for all k. This is one way to solve it. This is the the easier way by using the Euler's formula, because we have cosines and sines in the signal. So it's easier to go through the Euler's formula, and then we directly found the coefficients, those 4 coefficients, and all of them are just 1/2.